Hello, hello to all of you people out there. My name is Andrey. Today we are going to be talking about world configuration as code via Terraform, stories from trenches. But before we start, there is a little bit of warning, as many of you probably, I'm presenting today from home and you are watching it from home, and I have the kids around and they might be doing the kids thing. So if you hear any background noises, sorry about that. Well, but that's a situation we're all in right now. And talking about kids, there is a quite nice book or game that you can play with a kid, looking for the differences. It don't have to be necessary to be 3 differences, but you know the idea. It's quite educational and engaging, and also helps to build up focus and attention for details. But what you don't want really to do is to place that game on your production servers, especially when there is outage going on. I mean, that's no fun trying to figure out what the difference between those servers and why this one is working and that one is not, especially when you are considering that you might have intrusion going on, because then it's getting really, really scary. And today we're going to be seeing how we can avoid this situation altogether. My name is Andrey, as I said. I'm a technology specialist working as independent consultant, doing mostly remote work nowadays, and being quite a big advocate of the remote work, also having a kid and doing quite a bit of endurance sports. I'm fixing automations, projects, and organization that's my primary subject matter expertise. And I'm organizing meetups, conferences, in particular continuous delivery meetups, HashiCorp user group meetups, was involved in the PyCon Sweden, and a couple of continuous delivery conferences. I do speak quite a lot. Today, this is my first session. I will have another one on continuous delivery later today. So this one will be technical. And if you like something enjoying, like a story, then you should attend my second talk. And I also train people in Git, Docker, Jenkins, a bit of Kubernetes, and have plenty of certifications, which is not that important for today. So I'm not really pretending to be an expert. I'm sharing what worked for me with the clients, and there will be quite a bit of technical details and references, so be prepared for that. Slides will be available online. I will be posting them on my LinkedIn, and I'm pretty sure that conference organizers are gonna be collecting slides and sending them out. And also the session is recorded, so you're gonna get it in one way or another. And we're going to be talking about Terraform. If you are not familiar with Terraform, this is the tool that allows you to implement your infrastructure as code. And people might not be familiar with what infrastructure as code is. Infrastructure as code is when you configuring your infrastructure by calling some kind of APIs provided by infrastructure provider. So for instance, you have like infrastructure as a service or platform as a service tools. And Terraform allows you to automate calling those APIs and declare all the infrastructure as a declarative spec. So you outlining your intent. You say, I want to have this number of servers with those DNS names, with those load balancers. And then Terraform takes that spec that you provided and calls APIs necessary to implement that. And hopefully, everything goes smoothly and you get your infrastructure in place, exactly as you described. And then later on, you could do a plan. You could say Terraform plan, and Terraform will call the APIs again. It saves a state of your infrastructure as last time I checked, and it will compare the current what you have in the cloud or whatever infrastructure provider you are using with what you want and with a state, and then they'll say, well, you got this, and there seems to be a configuration drift, which means that infrastructure have changed comparing to your outline intent in your spec. So if you do Terraform apply again, it will try to bring your infrastructure to the way you intended it to be. So it allows you to automate the change, so developers could just write it all, and then you can roll out the whole infrastructure together with applications directly to production. There are plenty of open source models for Terraform, which means that you don't have to start from scratch. And there are a lot of best practices around Terraform. So it's a quite developed field, I would say, and a quite nice tool to use. And another important thing here, it has providers for almost everything nowadays. And by provider, I mean it's a small binary thingy, like a plugin that tells Terraform, what will translate the Terraform spec into the API calls and does API calls, which means that, for instance, if there is some infrastructure provider that's not supported, you could write the Terraform provider that would automate calling those APIs and parsing the spec. So you can translate the Terraform objects, resources into the API calls and get it to work for you. But as I said, there are a lot of stuff that is supported. You can think of all the public clouds, at least the biggest players out there. You can see like Pigdom, Cloudflare, and I don't know, a lot of stuff. And most of the things is possible to automate nowadays with Terraform, which is great. The Vault is another tool coming out of HashiCorp, and it's a solution for centrally managed secrets to reduce your secrets sprawl. And by secrets sprawl, it's understand that you have secrets everywhere and you don't really have a good grip of where they are and how they're being used. Another nice thing with Vault is it allows you to shift from static secrets, like for instance, having only one username and password for your database, to the short time dynamic generated ones. So you could generate database credentials on demand and then also revoke them, applying time to leave on those. So that's quite handy. It's also, by doing so, you're avoiding shared secrets. So you have a better audit trail because you have a shared secret, like a login and a password, and then everyone can copy it, use it, and you have no idea who is logging into your database and taking out all your PII or PHI or whatever you got in the database. So you only know that someone came in and took it, but you have no idea who did that. And also, Vault allows you to build a hybrid cloud solution. So you could have Vault in the multiple clouds talking to each other, and also your maybe on-site data store or on-site data center, I meant. And as well, it provides break glass procedure signs. Now everything is in one place and everything is dynamic. So technically, you have a possibility to just revoke all those credentials at once. And if you feel that you are intruded and you want to make sure that there are no data loss happening. Another thing is if you use the one password for everything, and by one password, I don't mean the password manager, but I mean like one database password for everything, then it's really painful to revoke that because everything gonna break. But with on-demand credentials, every application gonna get its own temporary credentials. So you could also get a better understanding of where the breach is going on. So plus you don't have to revoke everything. You can revoke only compromised one, which allows you to simplify the response operations. If you're not yet convinced, there is a great video by Armand Dankar, one of the co-founders of the HashiCorp, explaining all of that in the bigger details. And I don't have much time to go into those details, but there is a video. Check it out. So, considering I'm convinced you that it's a good idea to use Vault and use it with Terraform, well, about that I probably will have to convince you. But let's assume we are sold out on Vault and we're thinking, where do we start? And the good thing to do is to collect requirements and clarify context. By that, I mean, you should ask yourself a couple of questions before you start. You probably already have some infrastructure in place, and you need to decide how you're going to be using Vault. I mean, how it's going to be deployed to that infrastructure that you got. For instance, are you running containers? Are you running VMs? Are you on bare metal, right? So that's a first thing to consider. Then another thing is, how do you manage Vault installation itself? So for instance, you're running on VM, and will you be patching this virtual machine with the latest security patches for operating system? Or would you do a rather immutable infrastructure? So you're building the golden images and then just wiping what you had, bringing in the new image. That's another decision to make. And I would say Vault works with both approaches, since you could have your secret storage not necessarily in the machine, but somewhere else, and then machine is disposable, virtual machine is disposable. How you as an operator, your developers, your applications, and whoever needs to access Vault is going to access it. So that's another question. Then how do you gonna unseal it? And unseal is operations that you do in Vault in order to make it operationable. So when you just initialize Vault, by default, it will give you 5 keys that's used to construct a master key. And you will, by default, you will need to provide 3 out of 5 to construct the master key that is used to encrypt the storage of the secrets. So doing that after every restart is, well, not convenient, I would say, since you would have to have those people with those keys around to enter them so the Vault can get operational again. But the good thing is that HashiCorp a year ago unsealed open source auto-unseal procedure with a cloud provider. So you could use, for instance, AWS KMS. Vault can use AWS KMS to auto-unseal itself. And I'm not sure if it's storing its master key in KMS, but I think it's encrypting the master key with KMS key, and then you're using KMS to decrypt master key, and then master key to decrypt the storage. Then how do you get initial secrets, right? For instance, you want to have TLS certs for Vault. How do you get them into your installation? You might store them in Vault, but then you have a chicken and egg problem. So those are questions that you will have to answer. You might encrypt them with another KMS key, right? Which is only available on the infrastructure. So if image got stolen, then it's not a big deal because people cannot decrypt them, but depends. Depends where you run and what capabilities are available to you. Then what storage are you going to use? Like there is a HA storage that allows you to do HA, and there is a just storage. Like for instance, if in terms of AWS, if you do S3, this storage backend doesn't support HA. If you do DynamoDB as a backend, then it does support HA because then you can log objects and stuff like that. So you need to see what is available to you. And also, since you're going to put all your crown jewels into the Vault, you want to have this thing as secure as possible, or at least minimize the need to logging into this one, right? So then you need to find to see what capabilities you have for streaming logs out of the installation, capabilities to stream telemetry, capabilities to extract audit files. Do you need to run multi-cloud? Do you need to run hybrid cloud? That's another consideration. And another thing to consider is, will you have one Vault per all your environments, or will you have one Vault per environment? There are pros and cons for both, and you will have to ask those questions. And that will give you an idea, well, where to start, because the good question usually contains half of an answer, and those are the questions you ask. And then when you answer those questions, and you look for best practices and templates. The good thing is that there is a number of things that you could take advantage of. So for instance, there are Terraform models available in this open source, and there is one coming from Grantwork. There is also the Vault Helm chart that you could apply if you're running on Kubernetes. And there is a terrific resource provided by HashiCorp, learnhashicorp.com, where you could learn about reference architecture that they propose. So there are some things out there that probably will not get you all the way through, but it will be some better than start from scratch anyways. And again, as I said, you're gonna put all your crown jewels in there, so you probably want to have this thing secure. And that's like minimum readiness checklist, like the production readiness checklist, and that enlists the hardening that you might consider doing. And some stuff which is kind of obvious, TLS termination, for instance. Like when you, for instance, running on a virtual machine in AWS and you terminate SSL on your load balancer, then surprise, surprise, all your traffic between load balancer and virtual machine or like EC2 instance goes unencrypted because you stopped SSL traffic in here. So you don't want to do that. You actually want to have TLS certificate on your virtual machine instead, and then DLB just bypass traffic to the virtual machine, and then Vault terminates TLS connection for you. So, some basic things that I'm pretty sure everyone are aware of, but still listing them just in case. And, then local storage encryption, HA storage encryption, making sure that there is no SSH port open and firewall doesn't allow that. So person who wants to go SSH there have to take additional steps that you could be alerted about. So for instance, if someone opens SSH port or change the firewall to your Vault, you could have that as alert and react quickly, or even have reactive security, maybe like Lambda function or AWS config that reverts the change back to how it works. So making sure that no one gets in there. Another thing is like syncing audit files to out of your Vault installation. And as far as I recall, audit is not enabled by default, so you will need to make sure that you configure that. And last time I checked, which was actually a year ago, so it might change, HashiCorp recommended to store files, audit files, to the local disk, and then use some third-party solution to get them out to the storage available for you. Maybe they support something else now with our latest releases of Vault, but then you need to think how you do that. So for instance, you might sync them to S3 bucket and then make sure that you have MFI delete on that bucket. And you might even want to have that bucket to do cross-regional replication to another account, like a black hole. So it can only go one way, meaning that if someone would attempt to tamper the audit files, you still have a copy in another account, which is harder to get to. Right, and things like that. And again, learn HashiCorp.com, the link down below. They provide a quite nice guidelines about production hardening. So that's a lesson learned. It should be a story from trenches, right? And that's the one. You really want to split, or I do recommend splitting Vault deployment Terraform spec and Vault configuration Terraform spec. Let me explain what the difference is here. Vault deployment spec, like Terraform spec, would call your cloud provider to set up everything that's needed, like HA storage, virtual machines, or maybe container instances, whatever you got there. And load balancers, so making sure that all infrastructure is out there and applications deployed. Vault configuration Terraform spec is using Vault Terraform provider to call Vault itself. And you don't really want to do those two things at the same time, since what might happen, like for instance, you do a rolling update of your Vault servers, and you're not supposed to get any interruption since you're doing rolling update, and you always have a number of servers running to handle the request, but it might happen so that there will be a network glitch or something. And exactly at that moment, your Terraform will try to call Vault, and it won't able to do that because there is a network issue, it cannot connect. And then it will be stopped dead in your tracks, rolling out your infrastructure. And you are like in a no man's ground. So your infrastructure deployment haven't finished really, your Vault configuration is midway, and then you need to recover from this situation, which might be quite complicated. So you would have to do a lot of manual changes. It's much safer if you roll out the infrastructure change for Vault as a separate operation comparing to the Vault configuration as such. So like on Tuesday, you might roll out new virtual machines and changes to load balancers and whatever you have. And then on Thursday, you actually update the Vault integration itself. Just separating that in with some time frame so they don't interfere with each other. And it don't have to be 2 days, it might be the same day, but just put 5 minutes in between those two operations and don't merge the specs. Plus, the lesser Terraform specs, the more maintainable it is. So now you got Vault up and running. What do you do next? By the way, the Slido thing, I have it running on a separate screen. So if you have any questions, if something is unclear, just don't sit with your questions, drop them to the Slido. And if I'm still on the same slide, I will try to address it straight away. If not, I will take them in the end. But remember about the Slido thing and ask questions there. Right, a little bit of tea. So now we have Vault up and running. What do we do next? In order to employ Terraform provider for Vault, and I should actually give a big kudos to HashiCorp team that worked on a provider. In 2018, I attempted the Vault training from HashiCorp, and there were a lot of people like asking how do we configure Vault. And in 2018, the way to do that was to use Vault CLI or like Vault API and call all APIs or run CLI commands one after another. Just within 1 year, like across end of 2018 and then half 2019, the HashiCorp team did a huge progress on provider. And nowadays you can configure almost every aspect of Vault using provider. So a big kudos to HashiCorp on that. Right, so in order to use that amazing provider that is now available for all of us for free, we will need to have Vault URL accessible from the place where you're going to run Terraform from. And then the Vault, you will have to set it as a Vault other environment variable. You will need to have a Vault token with sufficient policies to configure Vault. If you're running first time, after Vault initialization, it will output you a root token, which is like a God mode. You can do whatever you like. And I do recommend using that root token for initial configuration to configure policies and auth method that we're going to be discussing later. And then just revoking this token completely because it's a God mode. It's a God mode, and you don't really want that token to be stolen from you. And you cannot steal what doesn't exist, right? So the best way to protect the root token is to not have a root token. And then you might ask, what do I do if I need to have a root token, right? You use those 5 keys that Vault outputs to you. And by the way, you can configure Vault to have more or less keys. It's just a configuration setting. So you could use those keys to construct a new root token, an issue new root token. But that will require some manual effort. And this is what you want, because you don't want this procedure to be easy, because then again, it's easy to steal this token from you. And then all your hardening, all your hard work and went in the Vault instance, that was for nothing. Right, and then you will need to have an idea what you want to configure. This is how the token looks, by the way. So you get token ID, that's a thing that you use to communicate with Vault. And I think it's quite clever design. You don't use some other entity. It's you issue token and then you apply policies to the token. We're going to talk about that. I'm getting a little bit ahead of me. And it also has a TTL, so it's going to expire quite soon. So that's another nice design in there. And you have to be aware of those. And by those, I mean TTL and max TTL, because TTL means is how much this token has to live more, and you can renew the token, but there is a max TTL that prevents you from renewing it above that value. So you want to consider setting those correctly. And this is one slide that I used to explain Vault. And on the left, you have auth methods. So you could leverage some as identity system, as identity provider, to actually authorize in Vault, log into Vault, and get Vault tokens that will receive Vault policies depending on how you configure auth method. And those Vault policies and Vault token, well, basically Vault token with the Vault policies applied to it will allow you to interact with secret engines. And you, for instance, can get temporary database credentials. You can get temporary AWS keys, maybe RabbitMQ. And there are a lot of secret engines that you could configure. There are also possibility to store the static secrets. So it's a KV, key value store. You could access that one. And still, well, you will not have a temporary access because it's a static secret. You just still have a better audit, so you know who accessed those. You could encrypt data in transit, and you could even use Vault as API, your public key infrastructure, and issue certificates. Plus, everything is being audited. So this is how it works in general terms. So we have to start on the left with auth methods and policy. It's kind of boring, but it's important because that allows you to get a token and to do other stuff that you want to do with Vault. And there are a lot of auth methods available, and that's a screenshot. It's not ends down here, it's carries on. So I took it from the Vault website, and you should check it out. You probably will need more than one. So you will need something for humans. You will need something for machines, like your ICD system. And you will need something for things. Well, you could argue that machines are things more or less the same, but I'm just trying to find a way to separate them. So you have your applications. They will need to access secrets. So they also need to have tokens and way to authorize. And then it's a good idea to use MFA where it's possible, because it is preventing unauthorized access. Also, there is a way to limit from where you could call Vault. I'm going to show you later. So the way it works, you would configure auth method, you will configure a role, and that will result in a token with a policy. For instance, in case of you have LDAP, you have LDAP backend group, which is kind of a role, and then you will get a token with policy. Let's see how it looks like. And just a couple of words of LDAP. It's really nice that you have existing, if you're using LDAP, for instance, right? So for instance, if you could use JSUIT and then translate JSUIT to LDAP, for instance. And you could use that to be used by humans. You could leverage existing organization structure in there, and you can delegate credentials validation. So it's quite a nice setup to have. And also, it's like an SSO, so people don't need to remember a lot of passwords. Well, here comes a snippet of Terraform code and a presentation called doing Vault with Terraform. So you knew that's going to come, and here it is. And yeah, it's not the most exciting slide, but it's going to be a few more of those. So be prepared. And you configure Vault auth backend, and it's pretty straightforward. You just configure the. If you ever configured LDAP, you know what to put into those. Yeah, important part here is you will need to have a bind account that allows Vault to log into your LDAP server and query stuff. So you will need to provide the username and the password, and you don't want to store this password in your Terraform spec. So you want to pass that as a variable of some kind, or find another way. Then you configure LDAP role, and LDAP role basically says, if someone from LDAP comes to you with a group name DBA, so the LDAP identity has DBA group attached to them, well, then give them token with DBA policy attached. Quite simple. You don't have to name the policies after the LDAP groups, but it makes a lot of sense, and then it's less confusion really for people. They know that if they're in LDAP in DBA group, they're going to get token with DBA policy attached. And for a lot of people, it's like almost the same thing. So they don't really distinguish. And it's in some ways good. So it's less cognitive load, and people can spend more cognitive capacity on solving the real problems. And then you will have to define the policy. And here I just give you an example how policy could look like, and you just say like, I have a secret engine in here, and it allows to create, read, update, delete, list. And writing vault policies is complex. It's a topic for a separate talk. So we're going to leave it outside for the moment. And you would have to figure out it for your own, because in most cases, it's very organization specific how organization decides to divide their access rights. So as I mentioned before, you will need to have a policy to manage policy. So you need to create some kind of admin policy that would allow you to revoke your root token and start use that one instead. So you can use tokens with TTL, so that they get expired. So if someone steals that token from you, they have a limited opportunity window for attack. The policy is denied by default, so you have explicitly say what is allowed. Again, they don't have to match LDAP groups, but it makes sense to do so. And member of multiple LDAP groups get multiple policies. Kind of also makes sense and allows you to, well, to have a quite fine-grained policies. Things to consider. I mentioned to you that it is possible to instruct Vault from where to receive requests and from where to allow. So you could set like token bound CIDR. So you could not allow people from internet, just from random IP address, receive tokens. They have to be on VPN, for instance, stuff like that. You could say no default policy because your default policy might contain something that is not desirable for you. And then also token TTL and token max TTL we discussed before. Then you have uproll auth engine, and that one is I wouldn't recommend using that if you have better options, because it's basically login and password, and it has inherently the same problems as we discussed with database password, right? So anyone can take it and use it, and there is very little audit happening. But it might be so that you have, for instance, CI system, like when you're using Circle CI, which doesn't have access to your infrastructure in a public cloud. Then Circle CI doesn't have any means of authenticating using anything else. So then you would have to provide something like that. And so, well, if you have to do that, but if you have a better way, prefer a better way. So you have a better audit of what's going on. And again, you have initial secret issue. So you need to provide it somehow to the system that's going to be using it. And again, that's a possible point of compromise. This is how you configure it. You say, I'm going to have a auth backend called uproll or type uproll. Then you create a role saying that this is a role name and the role going to get those token policies. And you say like this. You could then you use your CLI to say vault write auth uproll role my role secret ID, and secret ID is your password. And you can read role ID like this, and that's your login. So you use role ID as a login, and you use secret ID as a password. Every time you do write -f, it overwrites your previous password and issues you a new password. So you could revoke the old one if you want to. You could do that using Terraform, so you don't have to do it manually. So you could create those automatically. And you do it like this. So you create a secret, and then you define like a key value using locals. You define a KV storage in your Vault instance, and you just store everything that you received in there, and then you can read those from Vault. Or you could have another process or another spec reading them from Vault using Terraform. So instead of doing that manually using console, you create this resource. It's basically you're creating a secret, and then this resource, then you basically save role ID, and then you save a secret ID to the KV, which is a map, and then you save this map to the KV store in Vault, and you can retrieve that from Vault. You could use Cloud IAM, for instance, AWS IAM. You can use Kubernetes service accounts, and other identity providers to authorize your workloads. If you're running on the public cloud, if you're running on a Kubernetes, so it's a really nice way to, and it actually solves the initial secret problem, because you already have some kind of identity that you can provide to Vault and let Vault issue a token for you. So this is how it works with AWS IAM. Again, you're creating the auth backend, type AWS, you create a backend role. So we kind of been through this process already, so we know type of resources we need. We create a backend role. That's going to be CI builder. We can configure different things. For instance, say like we want the token that you issue using this role to be only 60 minutes, valid only for 60 minutes. We apply this token, and then you have to be, the entity that requests the token have to have this ARN. So it have to have this role attached to it. So for instance, think of instance profile applied to the EC2 instance, or instance profile applied to the pod running EKS. And then we will need to have a AWS IAM user. We will need to have the keys, and we will need to have a policy. And that user and those AWS keys used for Vault to go into AWS and validate the information provided to Vault when authorization request comes in. So that's a policy. We want to check the user. We want to get role. And yeah, we're also allowing it to assume the role. So it will be a Vault cluster. So something that runs on the Vault with a Vault cluster role can assume this one. So makes sense, right? And then we're creating the auth backend client, which basically that's the thing that's going to be checking stuff for Vault. You configure it with the keys. For Kubernetes, you could use service accounts, and I did another talk for that, so look for it. This year, yeah, that's the latest recording. This year, I did this talk only on the meetup, so there is no recording of this talk from this year, updated talk from this year available. But if you're interested, I could send you the latest slide. So, and that's a recording from the last year on the HashiTalks online conference. So now you got a token. What do you do with that? Now you configure some secret engines to get dynamic credentials that will have a limited lifetime, that will prevent sharing, to implement break glass procedure and have a better audit. All those nice things we discussed before. So KV, again, we discussed it before. So that's a static secret storage. And I do recommend creating 2 types of those. That worked pretty well. So you want to have one for humans to store stuff. And then you have KVs for applications to fetch things. And those KVs for applications to fetch things from, those you generate using Terraform. So you would have Terraform reading stuff from the KV created by humans. And humans are messy, so they don't follow the structure. They store stuff in the way they like, and it's fine. So you just create a place for them where they could store things in the format they like. You don't have to be very structured. But then you use Terraform to read out stuff from there and put it in structure in the new KV, which is for machine, which is in a repeatable format. So you could expect your KVs for your applications to read from to look exactly like the ones, well, for all of them to look exactly like others. So they're unified. This is what I'm trying to say. And this is how you can configure AWS for getting the temporary credentials. More or less the same type of thing. You create a user, you create an access key, you create a policy, AWS IAM policy to create users, create keys, and then you create secret backend. So this one will issue the leases. It will issue AWS keys. It will go into AWS, create the keys for you, return them for the person who asked for the key. And here you could say, for instance, default TTL. So this one equals to 8 hours, I believe. And this one equals to 24, if I remember that correctly. math doesn't really add up. So it's 3. Yeah, it actually does add up. 8 by 3, it's 24. Yeah, so this is how I configure it for one of the clients. The old developer gets the AWS keys, which are valid for 8 hours, which in most cases is enough to do a productive chunk of work. And then when they're done, it just expires automatically. But there is a possibility to extend it life up to 24 hours. We're still limiting the opportunity window for attacker who might be able to steal those. For instance, if the endpoint, and by endpoint, security people mean your laptop, if your laptop gets compromised, for instance. Right, so then we have IAM role. And here we're getting like admin, and we say like assume role policy. We're providing the policy to assume. And you could have a different credential type to return. So you could return assumed roles, and you get a security token, the key, and the key ID, or you could create a user, actual user. It depends on your use case. In some cases, you actually have to have a user instead of assuming the role and getting STS credentials. I will just scroll through that because, well, that's just a boilerplate. And in the end, you able to do like this and voila, you get your keys. And that's an example I took from somewhere else. So here, the lease duration is just 60 minutes instead of 8 hours, but you could renew the lease. You see, it says lease renewable, which means that you could keep using those credentials by calling Vault and saying like, renew this lease. I still want to have it. And the note on the lease renewal is that you have to keep the token that issued the lease renewed as well, because if your token is revoked, then the lease revoked as well. And you can also use those temporary AWS credentials to generate sign-in to AWS console URL, and then you don't need SSO. You just use those temporary credentials. This is the guide how you can achieve that. And I got inspiration for that from this talk, Growing Vault at Hootsuite. I hope I pronounced it right. Amazing talk. I really recommend watching that. So database credentials. It is possible to configure the Vault to go into the database and create credentials for you, but I would advise against that actually, because it is really hard to create creation and revocation statements. You will have to provide creation and revocation statements to the database, so the Vault can revoke the token, the credentials. But if your credentials was used to create tables, relations, what have you, then you need to have your revocation statement to have a logic to transfer ownership of everything that was created to another user in another role within the database. And it's really hard to get, right? So I would recommend, like, if you're in AWS, just use RDS, IAM house, because it's like simplifies things a lot, and you can still take advantage of your temporary AWS credentials. The secret rotations. It is possible to configure secret rotation in Vault. So you could provide Vault with your root password for database and then say, Vault, rotate my root password. And then only Vault knows your root password. Again, then no one can steal your root password. And that's a little bit of script that you could use to go ahead and ask Vault to rotate your database credentials. Don't be afraid of that, because, for instance, again, in AWS, you still have RDS console. You can go and reset master password if the need arises. The same you could do for all those users that you create for accessing AWS and Vault. So you can just say Terraform taint, and then Terraform apply, and Terraform will go in and reconfigure everything with the new keys. There is a possibility to call a Vault API and ask it to rotate the AWS credentials, but then you will have a conflict with Terraform, because next time you run Terraform will say, oh, the keys I created, they're gone. I'm going to create new ones, but Vault already created new ones. And now you have 2 keys. And next time you're going to get a 3rd key pair, and that's not what you want. I mean, and you cannot really have by default. So I would suggest you do this, really. Unexpected findings. We're almost out of time, but I'm very close, so hold on with me. So key state issue, that's when you're using the data data resource in Terraform and you use data to read something out, and in our case, you're using data to read KV out of Vault and then use the data content to populate some other resource, you're basically reading a secret in Terraform from Vault and then passing it to another resource. What I noticed that time to time, I cannot really narrow it down, but time to time, if you manually update the KV in the Vault UI, then Terraform doesn't really reread the data. So the data will be stored in your state, and all secrets you're reading from Vault will be in your state, so you have to protect your Terraform state. But it will not reread it. And in some cases, you have to force it by saying Terraform state rm, and then you would say data.vault generic secret dot run deck auth. And that will, next time you run Terraform, it will create data resource again by reading it from Vault, and it will refresh the secret. And I spent a couple of hours trying to help a couple of developers trying to figure out what's going on, because we see the secret, we can read the secret, we can read the secret using the Vault CLI, but we cannot see it in Terraform, like what's going on. So the final thoughts, the Vault introduction is a journey. So, see where it will bring the biggest advantage for you, like the biggest gate for your business, and start with a small use case, implement that one, and then like carry on. This is how I did multiple times. And then it's actually a great foundation for building security first platform, so your developers have possibility to do a right thing. Instead of, it's really hard to glue security afterwards when your secrets all over the place. It's really hard to fix it. But if you start early with Vault, you have a possibility to build a platform for developers to use it from the day one, and then all applications they create, they take advantage of the Vault features like in-transit encryption, dynamic secrets, and so on and so on. And changing the application logic time to time might be not that straightforward. Then doing the Vault configuration as code is the most safe way you have got, and I hope that there is no discussion around that. Because it allows you to create reproducible infrastructure. It allows you to detect infrastructure drift and so on and so on. And there is still a little bit of glue needed here and there, but those places are less and less. So we're in a good place right now, I believe, to do things. And it is important that we reuse and share when it's possible. So we have more of those open source resources available. Since we have a strong need for the best practices, we need to share and keep learning from each other, because the more if we are all getting more secure, it's better for our customers. It's less data breaches, less personal data exposures, less other security concerns going forward. So, keep learning, keep sharing. It's important. And with that, we're arriving to questions. I'm a little bit over time, but I'm going to go through the questions over Slido. Science, it's a lunch break. So technically, I have another hour. Right, so let's see. What are your thoughts about writing HashiCorp Vault in Docker container? Well, I don't really have a strong opinion like virtual machine versus Docker container. I think both works. You will have to have virtual machine anyway, so you will have to run the Docker container anyway, unless you're running on a Fargate. But running on Fargate is kind of expensive for the 24/7. So you probably will have to run your Docker container somewhere. So you will still have to do quite a lot of hardening of the virtual machine, plus then do a hardening of container. However, having Docker container adds additional level of security. So then if someone gets to your container, well, when someone gets to your container, the person there have to take additional steps to get out to the virtual machine, right? To pivot to somewhere. So it's probably easier to start with. Actually, like if you have a Kubernetes, you could start running with Docker much faster, actually. But for the more solid setup, you probably will want to have a separate VMs anyway. Since, you don't really want to mix your applications in the Vault. You want to have separations between those. You don't want to rotate your application cluster and have Vault going down, because your application might be still will attempt to talk to your Vault cluster on a startup, and if your Vault cluster isn't available, that's quite unfortunate. So most probably you will have a separate installation, maybe a Kubernetes cluster, ECS cluster, whatever have you, to run Vault. And then it might be a little bit overhead, if you ask me. I mean, like having like Kubernetes cluster with all the masters and everything. So it's it depends really of what you got. So, and the virtual machines feels just fine. I hope I did answer your question. Like I'm personally running on virtual machines. Is it realistic for Vault to replace any password storage application that employees use on their workstation? Any tip to make it really user-friendly? So, right, so if I understand the question correctly, is it realistic to use Vault as a replacement for like 1Password or something like that, right? Technically, yes. Since what you got in 1Password, Dashlane, LastPass, all those applications is basically a KV, right? You have your login and you have your password stored, plus you have Vault. You have Vault. Oh yeah, you have a browser extensions to make it more usable, so you could insert your passwords and logins directly to the web page instead of going to application and copy it. So I don't know. I haven't heard about the browser extension for Vault. Maybe there will be one. I do recommend if you embark on a Vault journey, you do provide your developers with some wrapper around Vault CLI, because for developers, they don't really need to understand all those details. So make it life for them simpler. For instance, we build the tool that would automatically, that you just say like, I want to log into this environment. And that will automatically go to Vault, log in you using your identity provider, get your temporary AWS credentials, configure all your environment. The developers don't have to think about all of that. So, and the same, you could build something, some simple program leveraging the Vault API to get the secrets from the KV or get some temporary secrets. There is a really good case if you go with the database credentials to issue the read-only credentials for people to go, for instance, production database and see what's going on there. They have to, so they cannot change it by mistake by typing commands in the wrong window, how some people did recently. All right, and but integrating that to the browser, that probably will take more work. I hope that I did answer this question. So to sum it up, yes, it's a good replacement. For instance, we did move quite a lot from 1Password to Vault, and it prevents the secret sprawl. So, but then you would have to build a little bit of stuff around it to make it user-friendly for developers to use. So they have to think less. You want to reduce cognitive level for people. And that seems to be the last question. I'll give you a second to type one more if there is still anyone in there. And if not, well, thanks for coming. I'm gonna have another presentation later today. It's gonna be less technical. It's gonna be about continuous delivery, and I would be glad to see you there. Thank you.